There are two types of qualifiers in C and C++, type qualifiers and storage class specifiers. This is an example of a variable declaration with qualifiers. In this example, the const and static keywords are qualifiers. They tell the compiler that this variable will be immutable, that's the const qualifier, and that it will be stored in static storage space. There are two types of qualifiers. There are storage class specifiers and there are type qualifiers. The type qualifiers include const, which makes a variable immutable, that means its value cannot be changed, and volatile, which marks an object that may be changed by another process. This is commonly used for threaded and multi-user applications that share memory. And mutable, this is used to modify a data member from a const qualified member function. This is only available in C++. The storage class specifiers include static. Objects stored in static memory have life beyond the execution of a block. Static variables are commonly used for keeping state between usages of a given function. Register. Register variables are stored in processor registers. This qualifier is taken as a suggestion by the compiler. The compiler may or may not actually store the variable in a register. And extern. Extern variables are defined in a separate translation unit and are linked together at link time. The auto keyword is deprecated. It's actually been removed from the very latest version of C++ and will probably be removed from future versions of C. The auto keyword was used to specify a storage class. In C++ 11, the keyword has been repurposed as a special type. Even though auto is still a valid storage class in C, I recommend that you don't use the keyword. Auto storage is, as the name suggests, automatic, and there's no need to specify it with a keyword. Let's take a look at a couple of these qualifiers in code. Make a working copy of qualifiers.cpp, paste this into our working project and open it up. And here we've simply declared an integer and we're displaying it. I'll compile and run this, and you see it says the integer is 47. And if I come in here and I change the value of the integer to 112, and I compile and run that, you'll see the integer is now 112. Now, if I qualify this as const, and that makes it a constant variable, which makes it immutable, which means it cannot be changed. And now if I try and compile this, you'll see that I get an error. And if I hover over that error, it says assignment of read-only variable I. The const qualifier is actually very common. It's commonly used in objects for things in the object that should not be changed, even accidentally. Another very common qualifier is the static qualifier. And to demonstrate static, I'm going to go ahead and create a little loop here. So in this loop, we have two variables. I is the iterator that's part of the for loop itself, and J is an automatic class variable. Remember, automatic class still exists. It's just automatic. We don't need an auto keyword for that. And it's initialized the value 12, and then we add the value of the iterator. So if I run this, see we get I is 0, J is 12, I is 1, J is 13. And so each time through, J begins at 12, but it gets this number added to it. So here J is 12 plus 2, 12 plus 3, 12 plus 4. Now, if I put the static qualifier here, now J is no longer an automatic variable. It's not stored in disposable automatic memory. It's stored in static memory, and it gets initialized once, but it will continue to accumulate its values. So you'll see it works very differently here. Now J is 12 plus 0, which is still 12. So here J is 12 plus 1. Here J is 13 plus 2. Here J is 15 plus 3 and 18 plus 4. So J did not get reinitialized to 12 each time through. It's carrying its value. It's being stored in a separate space where it doesn't get reinitialized each time this loop starts. Static variables are very common for keeping state in functions and in loops. Qualifiers are used to change default properties of variables. Some of these, like const and static, you'll use frequently. Others are good to know about for when you need them or when you see them in code. Now let's delete our working file